In this question, we determine the absolute extrema of the function f of x equals 7x squared plus 1 in the closed interval -1, comma 2. So first, we have to determine the critical point of the function by setting up the first derivative equals 0 and solving for x. So let's find the derivative of f of x, which is f prime of x, and this equals we find the derivative of the right side expression. So I put 7 and write the derivative of x squared, which is 2x. This is according to the power rule, plus the derivative of 1 is constant, so it is 0. So we have f prime of x, and this equals 7 times 2x is 14x. Now we have to replace f prime of x equal to 0, so that we solve for x. So here we have 0 equals 14x, and from this we solve for x, and x equal to 0. So we found that x equal to 0 is the only critical point of this function. And now we can find the absolute extrema by creating a table for the critical point as well as for the endpoint. So let's prepare this table. The first row we put x, and in the second row we put f of x. We put all the x values including the endpoints as well as the critical point. So here it is -1, and then we put the critical point 0, and we also put the endpoint of the interval, that is 2. Now we have to find the function value at these endpoints as well as at the critical point. So let me copy the f of x, and this equals 7x squared plus 1. First, let's find the function value at x equal to -1 by plugging into the f of x. So therefore, f of -1, and this equals 7 times of -1 squared plus 1. This equals 7 times of -1 squared is 1 plus 1. This is 7 plus 1 equals 8. So I put 8 here. And now let's determine f of 0. So f of 0, this equals, we plug it into f of x, 7 times of 0 squared plus 1. This is 0. So we get 0 plus 1 is 1. So f of 0 is 1. Now we find f of 2. So replace x by 2 in f of x, and this gives 7 times of 2 squared plus 1. 2 square is 4, so it is 7 times of 4 plus 1 equals 7 times of 4 is 28 plus 1 equals 29. So I put 29 here. Now we have to look at the table and determine the maximum and the minimum value of the function. The maximum value occurs at x equal to 2, and the minimum value occurs at x equal to 0. So therefore we see that 2 comma 29, this is the absolute maximum, and 0 comma 1 is the absolute minimum. And so these are the absolute extrema of the function.